Okay, so we are focusing on page 7, which on page 7 we are talking about something incredibly important, which is linear versus exponential functions. And so we really have to take the time to think about, what do we know about linear functions? Well, we know that linear functions are based on repeating, adding or subtracting, we know that, the same amount each time. The standard form of a linear function, you better know it, y equals mx plus b. M is our slope, b is our y-intercept. Exponential functions are a little bit different. They're based on repeated multiplication. So this is that you're going to multiply or divide the same amount each and every time. The standard form of an exponential is y equals a times b to the x. A, oh, here we go. You guys know my board. It's like you guys are here right now. A is your y-intercept. And b is what you're multiplying by. Oh my gosh, can we get another? Oh my gosh. Alright, so b is our multiply. Okay, so both of these are super important, and we have to know them in order to answer the first example. So the first example says, 2 tables below represent a linear and an exponential function. After you determine which type of function the tables represent, well, write their equation in standard form. Meaning that it wants us to do 2 different things. It wants us to say which one's linear, say which one's exponential, and then write the equation. So when we do this, we're really just looking at what is the pattern? How do I get from one number to the other? So we know by x we should always go up by 1. So I see I'm going up by 1, plus 1, okay. Plus 1, plus 1, plus 1. All right, I'm good. But now I have to think, how do I go across the y? Oh, that's easy. 5 plus 5 is 10. 10 plus 5 is 15. Oh, that's not right. So I know I'm not plus 5. So I can't be linear because I would have to add. So I know I have to be multiplying. 5 times what is 10? Well, 5 plus 5 is 10. So 5 times 2 is 10. Okay. Sorry guys, you're going to have to watch me orient the board in the middle of the video. Because that's where we're at. See, it's just like real class all over again. Okay. 10 times 2 is 20. Oh. 20 times 2 is 40. 40 times 2 is 80. So, okay. I got my pattern. It's times 2, so I know this has to be exponential. So it wants me to create the equation for this table. So I'm going to go back up here. What do I know about exponential functions? What do I know about exponential functions? The equation I have right here. Y equals a times b to the x. A is our y-intercept, okay. My y-intercept is where I touch the y-axis, so x is 0. So I know my a is 5. My b is this multiplier. Well, my multiplier, I'm multiplying by 2 each and every time. So my equation, y equals a is 5, b is 2, and x is the exponent. That's how I know it's exponential. So I know that table 2 is going to be linear because it told me one is linear, one is exponential. Let's figure out the pattern. By x, I'm going up by 1, so I'm looking good. My y, what am I going up by? So 8, 9, 10, 11. That's 3. 11, 12, 13, 14. That's 3. 15, 16, 17. That's 3. 18, 19, 20. That's 3. So when I go to write this equation, y equals mx plus b, m is my slope. Each time I'm adding 3, so I know my slope is 3. B is my y-intercept. When I'm at 0, the y-intercept is 8. So y equals 3x plus 8. I have my exponential function and I have my linear function. Second example, the exponential function f of x equals 4 to the 2x is shown partially in the table below. Find the average rate of change over the various intervals. So they tell me what they want me to find the rate of change for. So remember, our formula for rate of change. Y minus y over x minus x. So at 0, I'm 4. At 1, I'm 8. So we label xy, xy. Y minus y, 4 minus 8. X minus x, 0 minus 1. We do the math. 4 minus 8, negative 4, 0 minus 1, negative 1. When I divide, negative 4 divided by negative 1, I get 4. So what I would like for you to do now is I would love for you to pause the video and fill in these other 3, finding the rate using the numbers they give you. Okay, hopefully you paused. I know you guys, and you probably didn't know, but I'm not going to spend too much time because we know this rate. So 1 is 8. 2 is 16. So you should have did 8 minus 16, 1 minus 2. Negative 8.
Mrs. Williams,
Over
please
negative 1.
come down to the cafeteria doors, Mrs. Williams.
Sorry guys, this has been all day, and I can't stop the announcements. 2 is 16, and 3 is 32. 16 minus 32, 2 minus 3. Negative 16 over negative 1, 16. Three is 32, 4 is 64. So I got my rates. 4, 8, 16, 32. Interesting. Those are numbers in the table, aren't they? They're the ones that go in order. So what is happening to the average rate of change as x gets larger? So as long as these x's are getting larger, the rate is going up. 4, 8, 16, 32. So now what is that going up by? How do we go from 4 to 8? I could add 4, but 8 plus 4 is not 16. So if I'm not adding, I'm multiplying. Okay. 4 plus 4 is 8, right? So 4 times 2 is 8. Okay. 8 times 2 is 16. 16 times 2 is 32. So just like that, I found the pattern. What is happening to the average rate as x gets larger? It's multiplying by 2. If I look at my equation, look what that multiplier is. That multiplier is 2 as well. So just like that, connections are made. Pause if you need to, otherwise we're jumping to 8. Alright, consider the linear function 20x plus 5 and the exponential function y equals 5 times 2 to the x. Both of these functions have y-intercepts at 5. So they're going to start at the same location. Using your calculator, sketch these two functions on the axis below. Label each with its equation. All right, so we're going to plug both of these into y equals. And I really don't care about the table because it says to sketch a graph, which doesn't even mean plot the points. All right. So I have a line. Both of them should go through 5. So I have a line going through 5. We know the one that's a line is y equals 20x plus 5. And then 1 is clearly a curve. Which is our exponential function. So explain the similarities of these functions' graphs. Well, the biggest similarity is that both of them have a y-intercept of 5. Both touch the y-axis at 5. The differences between these functions. Oh my gosh, can it get any easier than that? One is a line, one is a curve. If you need to, pause the video. Otherwise, we're going to move on to the bottom. The fact that the slope of an exponential function is always changing has interesting consequences. Below are several examples of mathematical word problems. As you read the passages, identify the key phrases that represent the slope of the story. Use these key phrases. Decide if the situation is linear or exponential function. A bank account balance that grows at a rate of 5% per year, compounded annually. It told me my rate is 5%. So let's dig in our memory banks to last year. The only thing we can do with percents is multiply. If we multiply, are we exponential or are we linear? If we multiply, we are exponential. The cost of a cell phone service that charges a base amount plus 20 cents per minute. I see the word plus right here. I know if I'm adding, I must be linear. A population of bacteria that doubles every 4.5 hours. My trigger word is doubles. Doubles means times 2, so that's exponential. For the first 28 days, a sunflower grows at a rate of 3.5 centimeters per day. So that means every day it's adding on 3.5 centimeters. Well, we know that's linear. The amount of bacteria in a culture triples every 2 days during an experiment. Triples means times 3. That's exponential. If you need to, you can pause the video. Otherwise, you have 2 things you need to do with this assignment. You have your homework page, and also at this point, you are able to answer these quiz questions for quiz 1.